All right, hello, folks. It is noon, so we'll give a few more seconds for people to trickle in. But this is a seasonal climate conversations. We're going to be discussing spring in your yard and garden with Sam Potter and Laura Irish-Hanson. Before we kick it off, I want to let people know or provide a little bit of orientation to this experience. This is a webinar, which means that the only people who are going to be able to speak are myself, Sam, and Laura. If you have any questions, there should be a Q&A button on the bottom of your screen. You can click that and put the Q&A in, and then we can I'll be managing that behind the scenes. And so when both Laura and Sam are done talking, we'll be able to answer questions and have a really good discussion. If there's something wrong with audio or something on that end, you can chat, and I'll be dealing with the chat as well. So if something comes up, you can use that. There is the option for closed captioning, should be at the bottom of your screen. If it's not there already, you can click more and click show captions so you can see what we're saying. It will not be as robust as watching Netflix because it's doing it as we're talking and it is not 100% accurate, but it can get you somewhere in the right direction if that will be helpful for you. And then before everyone leaves, we're going to ask y'all to fill out a poll just so we can have a better understanding of who is here and what we'll be doing. But with that, oh yeah, so my name is Christy Marston. I work on the University of Minnesota Climate Adaptation Partnership team, and I brought Sam and Laura here together to talk about climate, what it's going to look like, and what it means for us. So Sam is going to start us off. He is one of our climatologists on the University of Minnesota Climate Adaptation Partnership team. So he's going to give an overview of what climate change is going to look like in spring. So I will hand it off to you, Sam, if you're ready to get started.
Awesome. Thank you very much. Okay, are you seeing my slides?
Yes, seeing your
Great.
slides, hearing your voice, everything
Okay,
looks good.
awesome. I will get started then. Um, Hi, everybody. My name is Sam. I'll be talking a little about the climate science of past and future changes to Minnesota Springs. This picture is from 6 years ago at the beginning of COVID. My wife and I were living in Cambridge up in Isanti County. Most mornings that spring, I would walk in Beckland Park, which sits next to the Rum River. And this is a picture of the boat launch and some of the trails, which were all flooded out for several weeks that spring. This will be a whirlwind overview of some important things to think about with spring and climate change. I'm going to touch on temperature, precipitation, snow, heavy rain and drought, severe thunderstorms, and lastly, talk about a few ways that spring timing is changing. The link to my talk is at this QR code or the link shown on here. Also, feel free to just email me for the slides as well. Let's start with temperature change. Since 1951, Minnesota springs have warmed about 2.7 degrees Fahrenheit. I've made two maps here. On the left is the present day change in average spring daily minimum temperatures for the spring months compared to the 1951-2000 average. On the right is the same map, but for average spring daily maximum temperatures. March stands out with very rapid warming. April and May minimum temperatures have warmed, slightly warmer nights and early mornings, but daily maximum temperatures have actually decreased across much of the state in April and May. So springs have gotten warmer, but that warming is not evenly distributed across the months or the time of day. So if you think recent Aprils and Mays have been a bit chilly, here's some proof. Looking into the future, climate models project that spring warming will accelerate. This chart shows historic spring temperatures in black and two possible futures. The yellow line shows future spring temperatures under an intermediate emissions future where we rein in our fossil fuel emissions somewhat. And the dark red lines show a very high emissions future where we grow our fossil fuel use. Models project an additional 3.5 degrees of warming over the next 3 decades. And by the end of the century, models project that springs will be 5.5 to 8.5 degrees warmer than present day. Temperature change is, of course, not just about the averages. These maps show one way to think about how different future springs will be. Shown here is the projected number of April days over 90 by mid-century and end of century under an intermediate emissions future. 90 degrees in April has happened here before, but it's rare. What used to be rare becomes commonplace. By mid-century, much of central Minnesota is projected to see 3 to 5 April days above 90 a year, and that expands to 6 to 10 April days above 90 by end of century for the southern half of the state. And there's even a few hot days in north central Minnesota. One sure sign of global warming will be a constant creep of earliest day of such and such a temperature record. Um, let's shift to talking about precipitation. Springs in Minnesota have gotten significantly wetter. These maps show change in the 2001 2025 climatology compared to the 1951 2000 average. March has little change, but April and May have both gotten wetter across most of the state. Southern and east central Minnesota in particular have gotten wetter. For example, southeastern Minnesota now receives 2 to 2.5 more inches of liquid precipitation than it did at the start of the 20th century during spring. This large increase in precipitation is likely part of the explanation for why April and May have not warmed as quickly as March. Plenty of rain clouds blocking sunlight. Let's talk a bit about snow. So snow data is much trickier than data on liquid precipitation or temperature. If any of you are weather observers, you understand very well why snow is so tricky. Snow observations are usually snow depth, both the amount of new fallen snow and the amount of total snow on the ground, as well as snow water equivalent, the amount of liquid water that melts from either the new snow or the snowpack. In addition to the multiple measurements, wind also blows snow all around, so you often have to measure multiple times or make an educated guess as to the kind of the correct amount that has fallen. So these are two graphs I've made from snow data that show the change in seasonal snow depth. They go from October 1st to May 31st. The blue line shows the 1951 to 2000 snow depth over the course of a typical year, and the orange dashed line shows the 2001-2025 snow depth. I've split Minnesota into two sections. The very snowy Arrowhead stations are at the top, and the less snowy remainder of the state is collected at the bottom. Generally speaking, winter snow depth has decreased significantly, especially in the snowy north. Spring snowpack, however, has been much more resilient. March and April snowpack has not changed very much compared to the historical average. In fact, it might even have increased a little. So this is still preliminary work, so I can't fully tease out everything that's happening here. But one interesting thing to note is that total annual snowfall hasn't changed much in the modern era. If anything, it has likely increased a bit on average. So changes to snowpack are more due to changes in winter thaw days. We're getting more of those kind of January thaw days that decrease the snowpack. We have experienced big swings in snowfalls in recent years as well. For example, the winter of 22-23 had record total snowfall in some parts of the state, while the winter of 23-24 had very low snowfall for much of the state. Models project that springs will continue to get wetter with an additional 0.5 to 2 inches of spring precipitation by the end of the century on average. That change is shown in the graphic on the right for an intermediate and very high warming future. As it gets wetter, models also project that springs will get more humid, particularly during March and April. May actually get drier as it follows summer. Unsurprisingly, climate models show total snowfall decreasing in the future, but the likelihood of large snowstorms may actually increase for a while because very cold winter storms get access to a bit more water vapor, and so that can fuel larger snow totals. This will be particularly true along the North Shore as ice cover decreases on Lake Superior. As we see a decrease in the average snowfall eventually, alongside an increase in large snowstorms, we might get more dramatic year-to-year swings in snowfall totals. However, on average, snowpack will continue to get less and less reliable this century, just as we get an increase in winter temperatures and spring temperatures. Projections show spring snowpack disappearing a week earlier by mid-century and 2 or more weeks earlier by the end of the century. But changes in averages are not the main story when it comes to future precipitation. Let's talk about one of the fundamental ways the atmosphere changes as it warms. with large implications for spring hydroclimate and for gardeners. So for every 1 degree of Celsius warming, air can hold about 7% more water vapor. That means that a warmer atmosphere is able to hold more moisture, what scientists sometimes call a larger atmospheric sponge. So that means that if warmer air comes from a humid place like the Gulf of Mexico or waterlogged soils in the states south of us, that air is now going to hold more water vapor than it did in the past. However, if the warmer air comes from dry places like the desert Southwest or the Canadian prairie provinces, there's now a larger gap between how much water vapor the air can hold and how much it is holding. And so this thirstier air demands more moisture from plants in the soil. So that means in a warming atmosphere, both the odds of heavy spring rainfalls will increase, and during the dry years, the transition to spring drought will be more rapid. So it all really depends on where the air masses are coming from. Minnesota's climate and springs were, of course, very variable even before global warming, but here's a sketch of an idea for how climate change could enhance both the wet and dry extremes of future springs. So on the left is future very wet springs. Let's say winter temperatures are cold enough and we get above average snowfall and a snowpack that's able to stick around into early spring. If that snowpack is followed by climate change enhanced heavy spring rains and relatively cool temperatures, we might get waterlogged soils and above average spring flood risk. On the right-hand side is future very dry springs. So let's say we start off with a dry autumn that's followed by a warm, dry winter. So even if there's decent snowfall, much of it would melt during winter and lead to almost non-existent snowpack at the start of spring. So let's say that's followed up by a spring with very little rain, March or April heat wave, and very dry air coming from Canada with gusty winds. So that change, that kind of chain of climate change enhanced events would deplete soil moisture, it would stress emerging plants, possibly lead to flash drought, and fuel dangerous fire weather. So people at MCAP I work with are studying floods and droughts to put harder numbers on the type of scenario I'm laying out here. And while it's still a bit early to say this with total confidence, it does seem like climate change is going to make both of these extremes more likely in the future. As well, as I argued in the previous slide, in the future, it's also going to be easier to jump from a dry spring to a very wet spring or vice versa, depending on where weather systems are coming from. So warmer, more humid spring air means more frequent and intense heavy rainfalls and more spring severe thunderstorms. Climate models aren't great at capturing extreme precipitation, so this is still difficult to properly quantify, but future wet springs will likely be wetter than the wettest springs of the past, and summer-like heavy downpours will creep earlier and earlier into the year, as a warming Gulf of Mexico means warm fronts deliver warmer, more humid, and more energetic air up to Minnesota. That energetic air will also fuel more frequent and intense spring severe thunderstorms. On the right is a graph of the annual cycle of severe thunderstorm warnings in Minnesota. You can see that severe weather season historically really kicks off starting in May, but that will creep earlier into the year as springs warm. Climate change is projected to mean more and more intense March, April, and May severe thunderstorms. Um, on March 6th of 2017, Minnesota experienced the earliest tornadoes on record. That's the kind of thing we should prepare for more of. More spring tornadoes, more spring damaging hail, and more damaging storm wind gusts in the spring. There have been several headlines in the last week that are warnings about spring severe weather season perhaps getting more dangerous. You might have seen the news about the deadly tornado in Michigan less than a week ago. Preliminary surveys show that tornado is the earliest EF3 tornado in state history. And additionally, in a different severe weather outbreak 2 days ago, Illinois weather observers found a 6-inch hailstone in the northern part of the state, which, if that is confirmed, would be the largest on record by an inch and a half in Illinois for the entire year. And so that record was probably broken in early March. That's very impressive. I'm going to spend the rest of my slides talking about spring timing. So we've already talked about a few aspects of spring timing already, like loss of snowpack or the first summer-like temperatures of the year. You all likely have your own phenomena you track to tell when spring is really here. One that I like a lot is the return of sandhill cranes, which are very easy to see and to hear. So hopefully you can see my screen here. I've switched over to a graph that I make for Cedar Creek Ecosystem Science Reserve up near the Anoka-Isanti border. So this shows the date of first sandhill crane sighting, or the first time you hear them, because they have a very unique call. And there's a steady trend since the early 1980s of sandhill cranes arriving 4 days per decade earlier. Um, and that's just a very, very steady trend. And so that's probably more a reflection of how spring is changing in the place where they overwinter as opposed to our springs, but it's kind of a reflection. So kind of unfortunate that they just arrived just in time for this huge snowstorm that's about to hit us. Another sign of spring that I think about a lot, more of a sign of late spring as opposed to early spring, like the sandhills, happens at my parents' house out in west central Minnesota. The first really warm stretch brings out the Asian lady beetles from all their places they've been hibernating over the winter, and they start to fill up the windowsills. And that's when my mom starts her patrols around the house, going from window to window with the vacuum to try to control them so they don't just fill up the house and all the light fixtures. So let's talk about another very Minnesotan example of the end of winter, and that's the breakup of lake ice and the amount of time there's ice on the lakes. So the graph on the right shows the change in the number of days with ice cover on Lake Minnetonka. The historic observations of ice duration and the historic trend are shown in black on the left. Um, Lakes in Minnesota are generally losing about 2 days a decade of winter ice cover. Most of this is a response to temperature, but lake ice breakup is also a function of things like wind, so there could possibly be some windiness changes showing up in these trends as well. The right side of the graph shows projections of future average lake ice duration. So this is very new work. Models project that lake ice losses will accelerate in the future with a projected loss of 3 to 5 days of ice cover per decade, depending on how warm it gets in the future. Of course, so these projections are specifically for Lake Minnetonka, and this is very preliminary work. I'm working on it right now, so those numbers might change, but it's just a sign that, unsurprisingly, lake ice losses will continue into the future, and they may even accelerate. One interesting thing about changes in lake ice is that while the average trend is downward right now, we are losing lake ice. In recent decades, we're actually experiencing more variability. And I think this is something we're all experiencing, more big swings in year-to-year lake ice conditions. Another very important marker of the arrival of spring is the date of the last spring freeze. The last spring freeze has moved forward about 3 days across the state in the modern era. So that stands in contrast to the date of the first fall freeze, which has moved backwards an entire week. So an earlier last freeze and a later first freeze means modern growing seasons are about 10 days longer. And so that's demonstrated in the maps on the right. The left map shows historic growing season length. The middle map shows modern change in the length of the growing season. And the right map shows additional increase in length of the growing season by mid-century compared to the present. So models project that Minnesota's growing seasons will get about 2 weeks longer compared to the present over the next 30 years. So growing seasons will continue to get longer here. Another clear sign of spring is leaf out. So to study leaf out, to kind of summarize the changes that happen to all plants, scientists use well-studied plants specifically to understand changes to plant timing, like the date of leaf out or the date of first bloom. So the specific model shown here is the SIX model of plants, and these are based on national observations of honeysuckle and lilac clones. So using weather data, you can establish a relationship between length of day, spring warmth, and the date of leaf out or bloom that's observed by volunteers across the country. And of course, different plants emerge from dormancy following a variety of cues in the spring, not just warmth, but the amount of cold they've experienced over the winter, soil temperatures, soil moisture, sunlight changes, and others. This SIX model, based on lilac and honeysuckle, clearly doesn't work for all plants, but is meant to give a general sense for how plants might change in response to warming. So let me go show another link here. This is the SIX model of leaf out for this spring updated this morning from the National Phenology Network. So the red colors mean spring is ahead of schedule compared to the recent average, and blue means spring is behind schedule. So those late January and February surges of cold air across the south delayed spring for those places that are usually warm. But those places that are colder, spring is charging ahead and across Kansas and Nebraska and parts of Colorado is more than 20 days early modeled leaf out. So this is one way you can kind of track the arrival of spring using this SIX model in the National Phenology Network. So the graph on the right on this slide shows change in average leaf out using this SIX model. The historic change is shown in black and projected change under intermediate warming future is shown in blue. There's lots of variability year to year, but leaf out has trended about 6 days earlier on average since 1951. That means many trees are waking up earlier, perennials in your garden are waking up earlier, weeds are emerging sooner, the allergy season is starting earlier, and so on. Climate model projections say those trends will continue. Climate models are a little more aggressive than recent observed changes and have leaf out trending about 1.3 days per decade earlier over the course of this century under an intermediate warming scenario. The blue shading shows the range of results from a collection of 24 models, which gives a picture of not just the average change, but a vision of what early and late springs of the future might look like compared to the past. You can also see how climate model projections are better at capturing trends, but don't fully capture the year-to-year variability of Minnesota's seasons. And the really good example of that is seeing the spring of 2012, which sticks out like a sore thumb here. So this is when we had the warmest March on record by a lot, and model leaf out was extremely early, almost a month early based on the recent averages. So this was the kind of spring that sort of the model ensemble I'm showing here would say wasn't going to happen for like 50 more years or 60 more years, but it happened in 2012. So this is just a sign that, climate models don't necessarily capture the extremes, so they do an okay job of capturing the average trends. And so who knows what the future warm springs of the future might look like. So for my last content slide here, a slide on spring mistimings or false springs. So I think we all have probably a pretty similar picture in our head of what we might call a false spring. Really warm temperatures at a strangely early time, just like last week. The scientific definition of false spring is more specifically plant focused. So here, a false spring is a hard freeze, 28 degrees Fahrenheit, happening 7 or more days after leaf out or any time after bloom. Basically, when the plant expected winter to be over, it's already made its transition to summer and it could very easily sustain freeze damage. So the first two maps on the right are historic and modern false spring probability. You can see that false spring probability is highest in the north and far south with a minimum across the center of the state. Um, the third map shows the change between the first two maps, so the modern odds of a false spring compared to the historic climatological odds. False spring occurrence has decreased across the center of the state, but increased in the southeast and the north. And the last map shows climate model projected change in the odds of a false spring by the end of the century. And generally, false spring risk decreases, but definitely doesn't disappear. I think my takeaway is that even as Minnesota springs shift to being earlier in the year, they'll always be variable. So my final slide, Minnesota springs have warmed unevenly across the state and the months. Spring warming is projected to greatly accelerate in the coming decades. The warming we've seen to date is really nothing compared to what's coming. The much warmer springs of the future have barely started to arrive. Minnesota springs have gotten wetter and are projected to continue getting wetter on average. More warmth and humidity will mean more heavy spring rainfalls and severe thunderstorms. Snowfall is projected to decline in the future, though that hasn't happened yet. Snowpack has gotten less reliable and is projected to continue degrading as global warming continues. The transition to drought and the dry springs will be more rapid than in the past. And when things line up for a dry spring, we will see enhanced plant water stress and more extreme fire weather. Lastly, we talked about spring timing or phenology. Spring timings have moved earlier into the calendar, but with large year-to-year variability. Things like lake ice breakup, the last freeze, leaf out, first bloom, and other spring timings are projected to shift earlier into the year on average, but with continued high variability. And I kind of want to leave on that note. Spring will always be spring, even as it happens earlier in the year. It's just an unpredictable season. Thank you all for listening. If you think of a question in a day, in a week, or in a month, feel free to email me at pott0150@umn.edu. I'm going to hand it off to Laura now for some expert gardening advice.
I accidentally hit the button too soon, so it prompted me like take over their slides. I was like, no. Oh, silly. All right. Can you all see my slides and hear me, I suppose? Excellent. Thanks, Sam. Okay. Thank you, Sam, for showing all the data. That is great. And by great, I mean, sometimes feels alarming, but I'm excited to talk to everyone about spring gardening. Um, I know there's a lot in this outline, but let's just recap some of these climate change trends that Sam talked about. And I just want to emphasize that I'm going to talk about things that you should be thinking about for this spring in particular, not projecting out for your gardens in 2050 or 2070, So we're thinking a little bit more immediate future and what you can do here. All right, so just a reminder, in spring, we're really going to be focusing on that concept of it's likely going to be wetter and more intense storms. So remember, that means we're going to get more precipitation. And if you look at the data for across the year, that means we usually are getting more precipitation in a single event and less rainfall events happening. So we have in the summer usually is when we get a lot more dry periods between our rain events. For the more intense for our gardens, what does that actually mean? So we really, really want to focus on wind. And we want to focus on hail and the amount of precipitation. Those are the three things we look at primarily. So in the image here, this was a beautiful maple tree, but unfortunately, because of poor landscape choices, there was no mulch around the base of this tree. And so there's turf all the way up, which means that the mower equipment and the weed whips had nicked the base of this tree quite a few times. And so there was damage. So we had that extreme wind. This was 2 summers ago here at the farm at the Arvin Chaska. Wind gusts were like 60 miles an hour. It snapped this tree over. So you can see the root system was nice. It didn't lift the whole soil up like we saw in Beltrami County last year. But just want to put it out there that this happens in the early growing season from these extreme wind. It can happen all year round, truly, from the wind. I did want to pull this map. So this is what was reported for extreme weather events in June last year for Minnesota. And these extreme weather events that were reported are tornadoes. So those are the ones in red. And then severe wind is the blue and hail is in green. Now, Sam did a show for the climate looking March, April, and May. But for most gardeners, the vast majority of what we're going to be doing in our gardens starts in May and the beginning of June. That is when we're going to be really focusing on our spring or cool season plants in our gardens for the most of the state. So let's just talk about the impacts from some of these severe weather events is really what we look at on a day-to-day moving through with our gardens. So this is an image that I took from 2021 earlier in the season. You can see the leaves of these trees they're pretty new and a severe wind event happened. So you can see we lost about a third of the canopy from the shade tree. Of course, there's damages to the home and property, which is not great. But the long-term effects of this was a very shaded garden. And then with the loss of the limb, those shade plants, they were mostly like hostas and coral bells. They ended up getting burnt from the sunlight that then was hitting that garden. So when we're losing plants in our landscape due to these extreme weather events, we have to rethink what is planted there. We might actually have to take plants out. It's just something to really be thinking about if you do end up losing a tree in these extreme weather events, particularly in spring. And spring's a great time to be thinking about new plants to add to your garden anyway. So if to spin it in a slight positive, you might have the ability to change over some of your plants. So if we get more precipitation, in one event, and then if we go into dry soil, we have soil moisture fluctuations for a lot of places where we go from too much moisture in the soil for some plants to too little moisture, so way too dry. And some plants are more adaptable than others can handle it. But I want you all to think about what happens when we have rain on top of frozen soil. Okay, so if we have frozen soil and we get rain, that rain is not going to be able to penetrate down into the soil. It's going to run off. If we have bare soil in our gardens or in our landscape, that means that that soil may start moving with that precipitation, that rain. And in urban environments, that might go onto sidewalks, driveways, and go down into our gutters that pulls that soil down into our waterways. Of course, same thing happens if you're adjacent to an actual waterway like a creek, river, lake. Anytime we have bare soil that's frozen and maybe the top inch is thawed out, right? That rain comes, it can actually pull that soil away. So I did take this screenshot this morning. These are the current frost depths in bare soil. Usually these are taken in farm fields, and that's how frozen or how deep the frost layer is. So you'll see in the southern part of the state right now, 0 inches are reported where this data is being collected. And then once you get to the center and northern part of the state, it varies quite considerably between 6 inches, how deep the frost layer is, to 60 inches. A lot of things impact how deep the soil freezes. One of them is the type of soil. Was there snow cover when it was extremely cold for a long time? And it can also be impacted in your own garden where you might have soil frozen in one section because it's really shaded. It might be on the north side of your home, or it might be a really low spot where you have cool air that pools. So that soil might stay frozen longer than an area that's in full sun, for instance. Sam did mention the likelihood of spring floods. I did just want to, I did want to share this one just in case for those who don't remember 2 Junes ago, when we had the extreme flooding happening, particularly on the Minnesota River, that caused the dam to collapse and break in the Mankato area. Um, that is really detrimental, right? We lost trees. There was lots of videos, if you didn't see them, of trees moving into the river system, of like people's homes just being completely flooded and very damaging to property. But it also was really difficult and challenging for a lot of the plants that were there. And lots of people ended up seeing established plants die because of those flooding events. So I mentioned this a little earlier. When plants are exposed to too much moisture and then too dry of conditions in our growing season, and even in springtime or going from spring into summer, some plants are going to be better suited to that fluctuation than others. And this is true for both annual and perennial plants, although most annual plants that we are growing in our gardens they're pretty babied. They come from these great greenhouses, usually are inside where we've seed started. And so they're used to this cushy lifestyle, right? Not a lot of wind, not a lot of sunlight, perfect amount of moisture, right? Because we're very meticulous when we want to grow our plants. And then we put them out into the world outside, and then they have to be able to adjust to the fluctuations in soil moisture. Or maybe they don't and they perish. But this image here, I just wanted to show the foreground. So where it looks all brown, that is turf grass this was during the summer. And some of this grass is just dormant. It's a cool season grass, so it grows in the spring and fall typically. But it was so dry this is my friend's yard. They don't do any supplemental watering. A lot of that turf did not come back. It actually died because it got too dry for too long. But you can see in the background where the rocks and that beautiful little cat is sleeping, there is a milkweed. We have Karl Forester grass and mint. Those plants, those perennials, are a lot more resilient and adaptable when it comes to these dry conditions. All right, other landscape impacts that are important. Soil compaction. So how compacted soil is super important to understand and know because it's one condition that is almost impossible for us to overcome with plants. Most plants are not going to survive or thrive, right? We really want plants to thrive in compacted soil. And we can exacerbate soil compaction, particularly in the spring after a rainfall event. So when soil is wet and we walk on it, you can imagine, we're stepping down, we're compacting that soil. And that's problematic because roots need oxygen. And there's pore spaces there that get decreased, and pretty much you can think of them being squeezed out. And so then we end up having root systems of plants that are already there that end up really struggling because they don't have access to that oxygen. Or if you go to try to plant new plants in compacted soil, they might never take. They might not actually be able to root into that soil. But I do want to say you might have an extreme weather event, right? So say there's a big windstorm or tornado, there's stuff all over and you need to go pick it up. Of course, you need to use your best judgment, go clean up those things in your yard and garden if you need to. I did put this image of this trellis. So this was a trellis I was building in my garden in April of 2021. And it was a really dry April, at least where I lived. So I knew it was okay for me to go and stomp around where I was gardening for the spring to build my trellis against that fence. And then the spring rains really did come in May that year. I'm gonna kind of glean over this one a little, but just know that extreme environmental fluctuations, right? So if we go from really dry periods, really wet periods, hot temperatures, cold temperatures, we have wind damage, hail, that can really decrease plant productivity. And that's not just of our edible plants. It also can decrease productivity for plants being able to flower. If you get hail damage, for instance, can be really detrimental to our plants. If you want to know a little bit, I guess I'm not glossing over this slide because I can't help it. So this is an image of some zucchini I grew, and the one on the top of the image, this is an environmental condition. So this came from a plant that I was not watering with very well or very consistently. So I watered it during a dry period and it absorbed a whole bunch of water really fast after being in a drought-like condition. The whole plant had been wilted before. And so you can see that it has a deformed looking fruit, whereas the lower zucchini was on a different plant that I was consistently watering. So the soil moisture was very even. We had a nice, beautiful, perfect looking zucchini there. All right, so really quick, stress on stress is not good. So if we have environmentally stressed plants, so in the springtime, if we have plants that are sitting in a really inundated or really wet soil, right? Soil that has standing water perhaps, or just never gets a chance to dry out a little, that can stress the plant roots out. If those plants are stressed out and then have disease on top of that, or a pest comes in and starts munching on that plant, the plant is going to have a harder time overcoming those disease and pest pressures because it's already facing some type of environmental stress. So that was all doom and gloom. But what can you do? What can you do about all these things? So this is the crux. It doesn't matter what time of year it is, but we always want to be practicing right plant, right place. We want to choose plants that fit the environment that we have as best as we can. Okay. So if you're choosing a perennial plant, you want to make sure that it is hardy to our zone. And so I'm not going to go deep into that because that could be a whole different talk. But we don't grow plants that only survive up to Missouri and then try to grow them here. It does not work as a perennial. Of course, we want to know how much direct sunlight that area gets. What type of soil do you have? The amount of moisture. And that's not just in the air and in ground naturally. That also includes, are you going to be able to water with a hose to get that tree established for 4 or 5 years? Or do you have to have a watering can? Think about those things for when you're going to choose plants to bring into your landscape. And also maintenance aspects. So there are some plants that are very high maintenance that they need to be pruned every year. If you're going to grow some types of fruit trees in your backyard, for instance, right? They need a specific type of pruning. Do you want to go through that effort and time? So just keep those aspects in mind anytime you're choosing plants. All right, so for wet soils, we don't want to walk on them, like I said, but if you have to, I highly recommend dissipating your weight. So you can use boards. Some people will use like a 2x6, lay it out on their garden so they can walk on that. You might use plywood pieces, anything to get your weight distributed so you're not compacting an itty bitty footprint. You can think of this kind of like snowshoes, right? It's much easier if we have snowpack to walk around if we have snowshoes than if we are just in our regular winter boots. All right, I do just want to talk about planting dates. So Sam brought up that we have 3 years earlier in general for those last hard freeze dates. But I want you all to practice caution if you can. So if you have never seen this table before, this is the actual data for different freeze like frozen or temperatures, and then the dates and probabilities for which they will occur. That sounds very confusing, but let's walk through it. So this is specifically for the MSP airport, so in Minneapolis. And I just want you all to think about your annual plants. Most of those plants that you're putting out are warm season. They do not want to grow below 50 degrees Fahrenheit. When we are looking at these tables, the highest number here is 36 degrees Fahrenheit. That is much too cold for many of those warm season annuals that we might want to be planting out in May or maybe even April, depending on where you're at and what in the state. So I highlighted here in this box at 36 degrees Fahrenheit on May 17th, there's a 10% probability that after May 17th, that there is going to be a 36 degree, usually evening. That's usually when we see the coolest temperature. And by evening, I mean early morning. So I look at that top corner when I am personally gardening and when I'm at work and we're looking at plants because we do not want to potentially lose plants by planting them 2 or 3 days earlier. So for instance, Mother's Day this year is on the 10th of May. And if you look here at the table, that falls between the 20 and 30% probability that there's going to be a day that gets at 36 degrees Fahrenheit. That is a big risk to potentially take if you decide to plant out those warm season plants on Mother's Day. To make this even drive this home, I think this is very important if you can't tell. So this is for MSP Airport. These are the temperatures from last May, the entire month. And so the upper bar is the max temperature. It's the darker. The lowest bar is the minimum temperature. So usually that's daytime temperature on top and nighttime temperature on the bottom. And the middle one is just the average. So you can see this graph goes from 40 degrees Fahrenheit to 90 degrees Fahrenheit. And Mother's Day last year, if you remember, was super hot, at least here in the cities, and everyone was really excited. And why does that matter for gardeners? Mother's Day is one of the biggest weekends for plant sales. Lots of people are going out, lots of people are buying plants, everyone's excited. I'm excited. I'm out at the sales, right? It's a very exciting time. But it was so warm last year, everyone had this false sense, not the true false spring, right? Because we're in spring now, but this false sense of, oh, it's hot, it's warm, we're in summer, we're cruising, it's gonna be great. But then 8 days later, you can see this extreme temperature dip, and at MSP Airport, which is actually a pretty warm area, so if you're just right outside the metro, very different situation, got colder, but it got down to 40 degrees. Now we know lots of reports, people lost thousands of warm season plants that they planted out after Mother's Day and between Mother's Day and Memorial Day because of this cold temperature that we just happened to get. So you know how Sam multiple times said there's individual fluctuations each year when we're looking at what's going on. This happens also within a single growing season, right? We can look day to day and have these extreme temperature changes. So just for reference, Memorial Day, once we hit Memorial Day last year, then we had more consistent temperatures above 50 degrees. So this is just to say, you know, take your own risks, right? Make your own assessments, look at the tables, and think historically what has worked well for you. If you do have to plant out close to those freeze dates or last frost date, use caution, and you can sometimes cover the plants now. Yes, this is an image I took of my previous backyard in the fall, but you can cover plants temporarily to stop frost from hitting leaves. You can use sheets. You can also use cloches, which are usually clear containers or milk jugs with the lids off. There's also for like tomato plants, you'll see them sold. It's these little wraps with water-filled cells because water will help hold heat and regulate temperature a little better. All right, other best practices, because I talk too much. I can already tell. I'm going to go over a little. Mulching is really critically important. And in springtime in particular, we want to get a good mulch in first. And I'm not going to go over all these benefits, but in spring, I really want you to think about, okay, if we're getting more intense rain, more rainfall, we want to slow soil movement or completely stop it if we can from coming off of our garden. Mulch can help do that. It can slow down water getting hit or soil getting hit directly by that rain and moving off site. It also can decrease what we call soil splash up. So if you have bare soil with your plants and you have soil-borne diseases, which there are quite a few, the way those soil-borne diseases can get onto the leaves of plants is from intense rainfall that splashes soil up onto them. So we can slow that down by using a good mulch. Of course, mulch can help suppress weeds if you do 3 to 4 inches, no more, of a organic mulch like wood. It'll slow weeds down. Remember, weeds are going to compete for light, water, and nutrients with the plants that you want to be growing. I think I already kind of talked about this, but just know your landscape. Soil is really important. Look for drainage issue areas and amount of sunlight. For soil in spring, why is this so important to kind of know what soil you have? I forgot to put the slide in here, but get your soil tested if you haven't already. You can send it into the UMN soil testing lab. But you want to know and have a good idea of what type of soil you have because the way water moves through those soil is a little different. So if you have a very sandy soil, those are going to have bigger pore spaces from those spaces where roots are going to go to get oxygen. It's also where water can kind of hang out sometimes. But if you think about having sand, right, in a cup and you pour water in, it's going to go to the bottom pretty quick. So water can move through sandy soils much faster than, say, a soil that has a lot of clay. Clay is very little particles, little pieces, and so it takes a lot longer for that water to move through a heavy clay soil. I'm not going to go into crusting, but that's also problematic for clay soils. Here's an image of my actual soil at my home, so you can see the different layers I have. It looks like children's play sand for at least 4 feet. In the spring, I never have standing water at my house, even with the extreme rain events we've had in the past few years. It always goes right through the soil that I have. I'm also on a slightly higher spot. For clay soils, this is taken 3 days after the extreme rain events from last year. Water was pooling. This is just outside my window here at work. And when water was pooling here in this very heavy clay soil, it actually started forming algae. So we had lots of other issues going on. Make note of where you have drainage issues and try to avoid planting wet sensitive plants in those areas. Look for plants that actually can handle some standing water. And a lot of plants, when you're going to buy them, will say, just that they can handle wetter soil. I'm not going to go into sunlight, but like I talked about earlier, if you have shade, you go to the garden center and you buy a plant for shade, and turns out you only have full sun, that plant's not going to do well, and vice versa. Protected areas can be from permanent structures or other plants. Like if you have a hedge, right, you can plant other plants to the east side of them, right? That can protect them from wind. It can protect them from direct sun in the afternoon, or you can do temporary protection like I have here. This is a type of shade cloth that I actually use. It's on the west side of my peas and lettuce so that I can harvest peas and lettuce into late June and July. All right, really quick. Adapting practices, okay? What can you do? Well, the best thing about this is good garden practices are good garden practices for all situations. And I know the climate is changing, but we're still going to be practicing right plant, right place. We're going to still be looking at mulching, all those things. But really what I want you all to think about is your mindset, because that is really going to be the most powerful thing. If you do want more concrete practices that you can use, there is actually a whole web page. It's geared towards vegetable growers, meaning vegetable farmers in Minnesota. But these strategies, you can use them as a home gardener. These 5 strategies in particular, I think, are very good ones to be looking at as a gardener. Of course, strategies and practices. If you have wet soil all the time, you can try containers, right? Containers are great. We can control the potting mix that we're putting in them. We can control where they are. We can move them from sun to shade. We can protect them easier, especially if they're on some casters, the little wheels, and you can wheel them into a protected site. There are, of course, different cultivars and varieties that are more disease resistant. There are also some that are more adaptable to different site conditions. I do just want to say this plant is not diseased. This is variegation. That just means there's two different colors on the leaves. If you're looking for disease-resistant vegetable cultivars, Cornell has a really great list. So if you just do disease-resistant vegetables Cornell, it pops up on your search engine. But if you're like, okay, Laura, I'm not growing seeds. I don't care about vegetables. Does this matter to me? Yes, it does. Anyone who is selling plants are going to be very proud to say, hey, this is disease resistant. This is adaptable to different site conditions. They want to make sure that you know so you can make the best choices. Now, if you can't tell, I love food and I love teaching people how to grow food. I always have downy mildew at my house. And so I was looking for a downy mildew resistant cucumber. So I clicked on that. That was an option I could do for searching. And then it just happened that this specific cultivar had all these other disease resistance, which is amazing. So make sure you don't just look at the little highlight if you're looking online for disease resistance. All right, this is the last thing, last two slides I'm going to put up for now. You are not alone. So all of this might seem very scary, right? All of this might just be like, oh my gosh, there's nothing I can do. And that's not true. You have community, even community that you maybe don't know yet or haven't tapped into. Talk to your friends, your neighbors, your family. Your neighbor might be 5 miles down the road, but they're going to be a really great person potentially to talk to about, hey, this extreme rain hit me and I lost this plant. What worked well in your yard, that kind of thing. So just really know that you're not alone. Talk to people. We're here. And also people who like plants, we're all pretty nerdy. Like we love to talk about plants. So just know, talk to us. We love it. And then if you all just do like right, a huge flood event happens or a big rainstorm sweeps your little transplants away. We're just going to let it go and it's okay, right? We're going to adapt. We're going to plant something else. Maybe you decide you just want to do a cover crop this year. It's okay. Things are going to change from your perfect spreadsheet. If you're like me and you have many spreadsheets with all your idealized plans for the year, you're going to change and adapt, and that's okay. All right. I'm going to just go fast here, other than don't try to conquer nature. It doesn't work. And I'm going to go to this one thing. Oh, and then if you want resources, I'll leave that QR code up for a second. So this is for a PDF to a longer version of this talk, but a lot of the resources are there if you're curious to find them. I'll send it back to
Awesome, thank
Christy.
you. Clearly, Laura has a lot of knowledge and a lot of information. So if you have any questions, definitely use the University of Minnesota Extension resources Laura provided. And it's likely that there are master gardeners or other folks doing some classes this spring to kind of think about how to adapt to a changing climate when it comes to your yard and garden. But I do want to reiterate also real quick, I have a horticulture background. So that is why I've been answering horticulture questions in the Q&A. If you're like, why is Christy doing this? I do know about plants and uh, interacting with those two is it really is, as the climate changes, it's going to be a lot more unpredictable and we just have to learn as we go about what we're doing. So, okay. We have a few questions. Sam and I have been answering a few of them as we go through, but we'll quickly get through these. And if you have any other additional questions, please put them in the Q&A. So the first I wanted to ask, so in the forecasts Sam, this is for you. Are the models considering the change in how the US is moving away from renewables back to a more carbon-based fuels for our energy production?
Yeah, so when scientists talk about climate projections, it's a pretty intensive process to kind of get to that point. So when climate models are run, they are run on scenarios, and those scenarios, generally speaking, kind of range from a future where the world cooperates and we move together very quickly off fossil fuels and thus limit global warming to a future where we're kind of at each other's throats. We rely on the energy resources we have, fossil fuels, and we continue to emit more and more greenhouse gases. And under that future, warming accelerates even more than it already is. So kind of the question is like between that future where everybody gets along and we move off fossil fuels and everybody doesn't cooperate and kind of uses the fossil fuels that they have, like where are we right now and where are we going? Um, basically, this is sort of an unsatisfying answer, but basically we're kind of like right down the middle. It's not as bad as the worst, but it's definitely not as good as the good scenario. And one big reason why it's not as bad as the worst scenario is that it just kind of turns out that solar and wind are really cheap and good, and they kind of outcompete coal on their own merits. And so that's a big reason why, for example, China has moved off fossil fuels so quickly, even though they do use a lot of fossil fuels still, and why Europe, and even the US has moved off of fossil fuels to some degree and will continue to. Um, so even with the recent changes and the clear importance that fossil fuels have to our economy today, we are not in line for the very worst scenarios. So far, it doesn't seem like it, but that could definitely change. And one way that that could change is if we reach certain tipping points in the climate system. So if the climate system decides to emit more greenhouse gases, things like CO2 hidden in the permafrost or the ocean carbon sink giving up, things like that. That could still push us towards these more pessimistic futures. But right now, our emissions aren't necessarily on that track, but there's still a lot of time to kind of decide that future. That's a very good question. Yeah.
Thank you. Okay, Laura, I have a question for you that might be a little bit out of the landscaping realm, but I feel like we could still get a good answer. So, if we have increasing potential for heavier rainfalls, is there a push to increase buffer zones along our springs and creeks to help prevent erosion? I will also note that we can also push as much as we want. So, I think the idea here too is that something you would recommend, Laura, and what does that look like?
Yeah, so there are legal setting, I'm pretty sure, for going up to creeks and streams, and I can't remember what it is, but I remember in grad school in Iowa, it was a big deal because Minnesota made like the biggest buffer of the Midwest. So it's pretty interesting. Um, but yes, so for your creeks, you want to slow down as much soil movement as possible. And with soil stabilization, without looking at individual creeks and soil and the vegetation that's there, it's hard to make any, for me at least, to make a concrete recommendation other than anything you can literally do to hold the soil where it is excellent. And I do know that there are resources. I want to say it's from the DNR, the Minnesota DNR, on this exact topic, which is why you won't normally find them on our extension pages because we try not to double dip with what they're creating. But I can try to find that.
Perfect. Thank you, Laura. Okay, we just have a few more minutes, so I'm going to ask the last question to Sam, which is the spring flooding that occurred several years ago. It seemed like the weather pattern had set up to keep a steady flow of rain coming over a period of time. Was that considered an atmospheric river type of event? I know personally, I haven't really ever heard of atmospheric rivers before. It seems like they've been hitting Northern California a lot more than normal. So you might also want to quickly define what that is.
Yeah, so an atmospheric river is kind of a sustained plume of water vapor that multiple subsequent frontal systems can tap into and rain. And so generally the way that we hear about it is the those systems that hit California that tap into tropical Pacific moisture. Um, some of them are called kind of the Pineapple Express when the moisture comes from a place like Hawaii. And then it hits the mountains of California and it can dump just a ton of rain. And you can get these sustained like 3 to 5 to 7 day events where multiple frontal passages happen and you just keep getting rainfall. We do get a type of atmospheric river here when we can get moisture coming up from the Gulf of Mexico. I don't know. I'm guessing you're talking about the spring of 2022. That was a wet spring. 2024 was also a wet spring. I don't know specifically off the top of my head if those were atmospheric rivers. Um, we we do we kind of have, I think, more dynamic weather than California. So generally, it would be more that we just got a few kind of big rainstorms. We were just kind of locked into a pattern. One thing that we do get is another circulation called the Great Plains Low-Level Jet. And so that is a sort of direct conduit between the Gulf of Mexico and the center of the country, kind of Kansas through southern Minnesota. And so if the Great Plains low-level jet gets set up, we can easily get a lot of rain over a period of time because it really sets up that funnel for moisture to reach us. But that's not necessarily an atmospheric river. I don't know the specifics of it, but there's a lot of way we can get kind of too much rain. So that's a very interesting question. Thank you.
Awesome. Well, thank you so much, Laura and Sam. We have hit our time. I've launched a poll, so before everybody leaves, please um, answer to know if we did well and what you like about this. And we will be doing another one of these. And we're not going to be talking about yard and gardens, though. We'll be talking about summer heat and how you can think about how that impacts you from a human health perspective. And we'll be doing that once summer kicks in. So look for that wherever you found out information about this one, and we'll talk to you soon. Oh, I did have a slide. Oh, it's lost now. Hold on, maybe. No, okay. Go to our website, which is climate.umn.edu, and you can learn more about the University of Minnesota Climate Adaptation Partnership there, including the upcoming webinar. Okay. Thank you so much, everybody. We really appreciate it.
Okay, really quick before you close it, Christy.
Yes. Yeah.
I'm going to add the link to the PDF that apparently wasn't working.
Perfect. And then I'll have those links where we post the recording as well. So if people lost it, we'll have that there. The survey should just be a poll that popped up on your Zoom. So cool.
You know, when the loading button just spins and spins and spins on Google Drive,
We love that. Yeah.
it's very helpful. There it is. Okay. Huzzah. Oh, I should have put
Yes.
something with it. Context.
Awesome. All right. Well, yeah, you can head out, Sam. We're done. We're just waiting until we have the last one. So, and I'm keeping the poll open a little bit. So, but yeah, I might end it for us. So thank you everybody for attending. We really appreciate it. We'll see y'all soon. Bye, everybody.
Thank you.